Intro and the Spencer-Welch controversy. Hello everyone, and welcome back to our lecture series on our other papers. In Lecture 1, we saw how we corrected a major crystallography authority on interplanar spacing. Today, in Lecture 2, we dive into a controversy that has plagued chemical thermodynamics and physical chemistry education for 50 years, the relationship between the total differential of Gibbs energy dG and the partial derivative del G/del Xi. Since the 1970s, textbook authors like J. N. Spencer and G. R. Welch have claimed that these two terms are not equivalent. They claim that their physical units differ and that they represent different kinds of mathematical changes. But today, we are going to show you that they are completely equivalent, and we will prove it using a beautiful, natural mathematical method we published in 2022 in the International Journal of Thermophysics. Mathematical Deconstruction, Equations 16, 17, and 18. Let us look at the mathematics. In equation 16, we write the total differential of G as the sum of chemical potentials times mole changes, plus the sum of mole numbers times chemical potential changes. Now, look at equation 17. The famous Gibbs-Duhem equation states that at constant temperature and pressure, the term, the sum of mole numbers times chemical potential changes, is exactly zero. Therefore, as shown in equation 18, dG simplifies directly to del G/del Xi, dxi. The claim that they are not equivalent is mathematically and physically impossible. The Gibbs-Duhem equation forces them to be equal in functionality. The concentration-based intuitive proof, equation 34. To make this even clearer, we bypassed abstract thermodynamics and developed an intuitive, direct proof based on concentrations and mole fractions, inspired by our 2012 paper in the Journal of Mathematical Chemistry. By taking the derivative of chemical potentials with respect to Xi at constant T and P, we directly evaluated the sum of n_k d ln x_k. The sum simplifies directly to zero. This elegant, simple proof shows that the Gibbs-Duhem constraint is a direct mathematical consequence of mass conservation, without any thermodynamic fog. Exposing the gatekeepers, EJP rejection. But when we submitted this clear, unassailable proof to the European Journal of Physics, they rejected it. The reviewers patronizingly claimed we confused total and partial derivatives. They failed to realize that while total and partial differentials are distinct for general math functions, G in thermodynamics is a constrained physical system where the partial differential term is guaranteed to be zero by Gibbs-Duhem. This rejection shows the deep-seated tragedy of academic authority. Peer reviewers often defend dogmatic definitions they do not truly understand, gatekeeping correct math to protect their status. But truth always prevails. Thank you for listening, and join us next time as we continue to expose scientific gatekeeping.